2, 3 years ago.
Yeah.
Since then, we've had about maybe 2 or 3 more developers that have added onto it and worked with us on it. So it's definitely not just ours. It's a community project. It's fully open source. So if you guys like what you see, please participate. We're totally down to taking on collaborators and stuff like that.
Yeah, and it's mostly a best effort project, so we kind of work on it mostly in our, our spare time. So there are a lot of things we're about to implement in addition to what we currently have. So some of the things are kind of raw. We're also looking for people to kind of help us either with development or with data points. So we're looking for places where we can host some of the honeypots.
So what we set out to do was create a reproducible data source for DDoS target data. And we also wanted to make it super easy to share because we don't, there's like a cost associated to generating this data, especially since the architecture requires participation in the attack. So anything that we do, there's like kind of a negative impact on the internet as far as collection of it. So we want to make sure that we make the data open so that people can receive it to kind of weigh out those costs.
Yeah, and you can also see that we're combining passive with active honeypots. As Tuna said, the active honeypots do contribute to some of the noise on the internet, so we want to be a little bit cautious and kind of mindful.
So just kind of go over the structure of how we're going to talk. We're going to give you a little introduction of what we're doing. We're going to talk about the problems we're looking to solve with the project. We're going to talk to you completely about the architecture and also go over the code. So we'll gradually get more technical as we go. So anyone that feels like it's getting too technical, can open up a seat for some people in the back. All right, so let's start with the problem. This damn cable! Need more beer. All right, so every time something fucks up, I'll have another drink.
Yeah, bring another case.
Oh shit!
Drink,
all right, drink
again.
Okay. So when we first started DDoS, can I get a napkin? Because you probably don't want to put on that nice shirt. I think I'm going to present for someone later. Here's a wet beer shirt. Thank you.
Here,
it's my picture. Here we go. Yeah, perfect. All right. It's not the first time I've been covered in beer. So when I first started doing this, I've been doing DDoS mitigation and research for a long time. And when I first came out here, we just saw a lot of syn floods and get floods, right? I mean, it was kind of boring. There was some reflection as well. But we definitely saw a lot of syn flood traffic. This is kind of just a scrape from TCP dump. This is kind of how we always visualized our attacks.
Drink, Tuna, drink.
What are you doing, man?
It's not working.
Oh. What the fuck, man?
I don't know. Yeah.
Does anyone have a better adapter?
Yeah.
Because it's the adapter that's screwed up. This is a great monitor, so if you have really good eyes, you can see an old Optima botnet. I don't know if you guys are familiar with that. But this is definitely an old Optima get flood. In the early days, I mean, like, a lot of the application-based floods were pretty much all from, like, Russian toolkits.
Allegedly.
Thank you, guys. Yeah, allegedly, right? Here's a dirt jumper. Or actually, no, this one might be an Iranian kit. We also did see some NTP reflection as well. So in like the early days, we used to see these really small reflection floods, these really small NTP charge in and rip. Now there was others going on. There was like SNMP reflection and stuff like that, but this was like a really small portion. The majority of our attacks were like syn floods and these get floods, from botnets. But there was a few intelligent people back then that were targeting mostly like Chinese gaming sites, Chinese casinos, with these really small, like 2 to 4 gig reflection attacks with NTP. So back then we would see NTP rip and charge in, and we're like, what the hell is this? What's going on? This doesn't make much sense. So we started doing some research on it. We opened up a paper, and then kind of floods, big attacks came out, where like 300 gig attacks for amplification mixed up weren't totally impossible. So we looked at a few reports. So looking at Akamai's report from Q4 in 2015, they stated that the majority of attacks that they had seen were infrastructure-based. So 97% actually. So that's a little bit more than the majority. So that's very interesting, right? So if the majority of the attacks are infrastructure based, then how many of them are SIM related, and then how many of them are actually reflection based? So we drew the hypothesis that a large number of these, or we draw the hypothesis that a large number of these are actually reflection based, and we believe that the majority of the attacks going on right now are reflection based. So our project focuses on that, which is good because we're able to see globally and externally from outside of any vendors the attacks that are going on the internet based on having these honeypots on the net.
Yeah.
And there's a reason for this, and I'll let Krasi kind of speak to
Yeah, and
this.
actually it's kind of interesting to look at the viewpoint. Those larger providers have an interesting viewpoint. They always are protecting some sites that are fairly visible, and traffic is sent to them when there's an attack. However, they don't see a lot of the attack traffic that is going between end users on the internet. So over the past 2-3 years, it has been extremely popular for people playing online games to deny of service each other. None of those is going to call Prolexic or Akamai. Well, now they're the same.
DefenseNet or Nexus
Oh,
Guard
yeah,
or whoever,
none of them
right?
is going to say, hey, you know what? Why don't you protect my home modem? You know,
For
it's-
$5,000 a
yeah,
month. Yeah. No,
exactly.
thank you.
Yeah, so it's kind of obvious that, plus they have latency issues as well, so it's also not possible to even introduce some of those mitigation technologies. So having said that, the point I'm trying to make is that a lot of the DDoS traffic is actually not seen by those providers because they have the point of view of, hey, large site being attacked, but how about all those small ones that add up? I mean, the booters, some of them can do up to 40 gigs. That's not prevalent, but you know, 40 gigs, or you know, most of them do at least 10 gigs. So think about 5-minute attacks of 10 gigs, and we have millions of users of online games that are denial of servicing each other. So that's a very large number. You can see on this slide, Cloudflare is the top provider from the large ones, and they're only ranking number 19 as the target.
So what that tells us is that all of the different providers that are actually producing these DDoS statistics are only getting a very small view or a portion as to actually what's going on. Now, we're not saying we have everything. We're just another piece of the puzzle, right?
Yeah.
But we do have a view that's external from any of the mitigation providers, so we have a more holistic view of this approach. So we theorize. So why don't you talk a little bit about reflection for the people in the audience that don't.
Yeah, this
that
is
don't
more
know
of a
that.
level set slide. There's not, you know, there's not much
This
to
is
it. But
actually
if you
C2s.
think a look,
We're
I mean,
monitoring C2s right here, the old school way.
yeah. So if you look at this, how did it start? Initially, we had an attacker. Then the attacker would be directly sending traffic to the victim. We're talking about 20, 25 years ago when people were executing SIM flood and the Linux kernel couldn't handle much of it. Then the next generation was you had an attacker and then a botnet. So the attacker would command this command and control server, and then from there the bots will be executing attacks and sending the traffic against the victim. Now, what we're seeing over the last 3 years is that we prevalently see a reflection where the attacker directly sends traffic that triggers the reflection, and the actual reflection is the attack traffic. Now, why is that happening? Well, if you think about it, going from step to number one, go back. Going from step 1 to step number 2, they needed that in order to scale so that they can have more traffic sent to the victim. However, it is extremely expensive to have those those bots recruited. I mean, you have to infect those people. Then instead of stealing credit cards, you're doing what, like sending traffic, and then you know they get burned really quickly. Not really profitable. But now, if you look at reflection, it has very low barrier to entry to recruiting your you know, weapon or the bots, and then they give you a fairly good return. So it's very low ROI business.
There's another piece to that too. With reflection-based services, it's a lot easier to hide your originating source from your victim. With the traditional CNC-based attacks, a lot of the actual like local ISPs that are based on like modems and stuff like that have instituted like BCP38 or you know source-based address filtering. So they're not actually able to spoof from those bots. So they've moved to reflection in order to hide the originating source of the attack as another means, which is another benefit of using reflection-based services.
Yeah, and another point actually, which we cover a little bit later,
Which in short just means you can't spoof from a lot of the home networks anymore.
yeah, and actually, if you look at some of the WordPress compromises, they also do not allow you to spoof because they're not run as root on the boxes. So anyway, continuing with the level set slides. So with reflection and amplification, just looking deeper into the problem. So you have a source, or you have the attacker that is going to send a packet, and they're going to spoof the source IP address of the packet so that the response goes back to the victim. And now when we add to this, a little faster now. Cool. And now, if we add a particular protocol that is conducive to this type of action, then we could very easily scale that up. So here in this particular case, I'm only showing 512 bytes, which was the default DNS like many years ago before the eDNS 0 extension came about. And here we're still looking at 8 times amplification, just out of nothing. Now, currently with DNS, we can do about 50 times. Now, looking at some statistics from the OpenDNS project, there are currently about 20 million OpenDNS resolvers that can be used as amplifiers on the internet. The data is of late last year.
Yeah, it's of October 15th.
Yeah, thank you.
So, I mean, so what we wanted to do was we wanted to actually be able to visualize all the traffic that is being sent to the victims, but is also being scanned from on the internet. So what we decided to do is build the honeypot that actually becomes the reflector. So back at the point of there being so many amplification services, there's 3.7 billion active IPv4 addresses on the internet roughly now, which in reality, I know there's a lot of articles that say you can do it in 45 minutes, but in reality, it takes about 8 hours to scan per service. So it's very easy with one of these two scanners, Zmap or MassScan, to quickly go out and see, like, okay, how many TFTP servers can I reflect off of? Okay, the answer is like 3 million. There's 20 million, DNS, 3 million TFTP. The numbers are pretty crazy. So these are all places or possible sources that we can identify, that we can amplify traffic off of, and use us to take, our 1 gig bad VPS that's about 100 USD a month, and turn that into 20, 50, 300 gig. In theory, obviously not that.
And that's back to the point of the low barrier to enter. It is a very low threshold. You're looking at, just getting the VPS versus having to buy a, kit, then do the downloads, the infections, then so on.
Totally, it's just one box. I mean,
Yeah.
one box you can generate a lot of traffic. So basically, what we were trying to do is we want to appear as a victim, we want to be exploited, and we want to log that. I love this picture. We actually had it covered up with something before from another
in a
place.
particular place, they didn't like the nudity there.
Yes.
It's too much for them.
So currently, the honeypot system that we have monitors all of these reflective UDP-based services. And we've written, so we do it with a mixture of either we make it ourselves or we use the original service. So in essence, what we're trying to do is we're trying to build a sensor. We want to put that through a message bus so that it makes it easy to share. It makes it easy for multiple people to authenticate and add data, so you can publish data, as well as have multiple people on the other end that can subscribe to that data feed. So when they subscribe to it, they subscribe to it in a JSON data format, and they can put it into any system they want, which is the beauty of it. One of the systems that we use for our major data analytics is Elasticsearch. We've been using this since like really, really early. I think we've been using Elasticsearch for like 3 or 4 years now, which is ridiculous. It's matured a lot. We're still running on the 1X platform. We rely pretty heavily on filters.
It has matured, we haven't.
Yeah, well, never going to mature. It gives us the ability to quickly and easily visualize our data as well. This is an old version of Kibana 3 that works really well with the Elasticsearch data. We were able to collaborate in multiple ways. We can provide raw data through the message bus in stream-based, form, or we can provide block-based analytics, which is processed analytics. So these are enriched and processed that can tell you, okay, it's not just a packet. This packet is an attack. If this attack was this big, possibly it contained these ports, and then we ship that out in an email digest. So anyone here that's actually wanting to receive this data, we'd be more than happy to share it with you.
Yeah,
For non-commercial reasons.
Yeah, exactly. We're very much open source, both on the code and the data.
Yeah. So what we have here in super small text, again, for those beautiful eyes, is a very simple JSON format. We have the IP, and depending on whether or not, this is the interesting part, right? Depending on whether or not it was an attack, like a target, or a source scan, determines whether or not the IP is a source or a destination, even though it's the same piece on on the one. This one's particularly a DNS attack. So, for example, we provide the query type 255, which is any star. It has many different forms. We provide the domain that it was using and the ports, as well as the transaction ID. So all this data gets to be open source for universities so they can kind of look at trends and statistics. Currently, our honeypots are based on Ubuntu 14.04, long-term support version. We've got, I think, like one more year until we got to update that. The installer is a really simple bash script, so it's really easy to deploy. Usually, like, rather than fixing them if they break, we just destroy them and drop a new bash script on them.
Actually, one of the thoughts behind the bash script is that it's also fairly portable to other distributions as well, so we're not kind of stuck with Debian packages or something like this. Not that it cannot be improved, but...
Yeah, exactly. To answer some of the questions, as someone asked earlier, like, well, what did you write your emulators in? So some of them are emulators and some of them aren't. It's interesting to see what happens to bind when it gets stressed. It's interesting to see what happens to NTPD when it gets stressed. All these services kind of act and behave differently. So, excuse me, it's the beer. So when we don't have to emulate, we definitely prefer to use the legitimate service. It gives you a better perspective of what's going on. You can see oddities occurring, right? Like, for example, there was an attack once where PHP was being overloaded and the connections on the box were being outbound overloaded, and we were seeing a SYN flood when in actuality it was an application flood. But there were no more open connections, and it was SYN flooding from PHP. It was really cool. Those are the types of things you get to see by running the actual service versus not emulating it. So this project originally started with the love and the idea of wanting to use Bro IDS. So basically, all the services run, those are just there to receive the request and then process their responses. But actually, all of the intel is actually generated from Bro. So Bro has some very unique use cases, I think, that can be used very well. And I think for honeypots, specifically even darknets, Bro is probably your best choice. Bro provides us with an easy way to index every single packet that's coming into our box, no matter what service it is. It gives us the ability to record that and then parse that very easily and process that in a JSON. And it can do it at extremely high rates. So any of the researchers out there who haven't gotten a chance to use it, I recommend it. We also wanted to use something that was shareable. So like we had mentioned before, we used AMQP, which is Advanced Messaging and Queuing Protocol. This works extremely well for the rates that we're dealing with. It gives us the ability to set and create queues in a way that, like, I can share information and I can also receive data. And then we sometimes visualize in Kibana, but not always.
Yeah, one other benefit that Bro gives us is the ability to hook on certain events and do some data enrichment in flight, which is another fairly, flexible thing.
We do most of our data enrichment with Logstash. So, like, on the host itself, we do a lot of our data enrichment with before it gets pushed out into the bus. That gives us better scalability. So if we had 100 sensors doing the data enrichment, we don't actually have to process that in our back ends. So this is our basic architecture, drawn out on a napkin, the best way. We're able to add and remove as many honeypots as we want. We process those over the internet. We do SSL from the honeypot to Rabbit. And then for right now, we push that into Elasticsearch via RabbitMQ. But the way that we've got it set up is if you wanted to push it off in anything else, it doesn't really require any architecture changes. So a simple sketch with a little more visualization. We have Bro generating all the log files, Logstash parsing those log files and then putting those into JSON format, also performing those enrichments, like Krezi mentioned, like GeoIP information, for example. We pass that with SSL, AMQP protocol to RabbitMQ, and then we actually just bring that back into Elasticsearch again with Logstash. So we're able to process hundreds of gigs a day, anywhere from tens to hundreds of gigs a day, with a small cluster of machines running in the Google Cloud platform. It costs us roughly $400 to $500 a month to process that much data, which is, I find, pretty awesome. I mean, I don't have to make that investment of like a $5,000, $10,000 server. Plus, I can scale out and scale down pretty easily, or we can. So this is an example. Again, just fuzzy little lines. Little cotton balls. If you could get the idea, we've got a dot there, a dot there, and a dot there. All these are the actual log files that Bro produces. Oh, we only have 20 minutes? I thought we had an hour. Oh, shit, we better speed this up. All right, next slide. Yeah, it's just D-message.
No, this is you encode. This is how we encode the tools, so they can be pasted in directly.
Our config files had a lot of regex, so rather than escaping that, which would be like a complete mess, I mean, we drink a lot when we code, so it would be a pain in the butt. So we just used an old malware trick. Works really well. Just base64, encode your configs, and then extract them out.
Well, and you can paste the entire script and everything in through the shell session without having to do anything more complicated, so it's very low overhead.
Yeah, so this becomes our logstash file, essentially, for parsing and dealing with our logs. It looks complicated, but it's super simple. These are just tab-delimited CSVs, essentially. And from this, you can quickly add any single file you want, throw it in for processing. Super sweet. This is the output piece. This is all you have to do to basically take the output data and or ship it off to RabbitMQ. Which again, like we're talking about these two configuration files here, being essentially all that you need to do to ship information in or out, which makes it extremely flexible and fast. We're not talking about massive code changes to want to start doing stream-based analytics or ship it in a Graphite, whatever, it's all there. Some quick little off-the-cuff favorite plugins I like for Elasticsearch. I love this plugin, Elastic HQ. Yeah, Elastic HQ. It gives me a really quick single pane. So if any of you guys use Elasticsearch, it's really neat to kind of see the health of all your nodes really fast. It also tells you about your size, how many documents you've got. Highly recommend it. Allows you to also like really easily delete indexes. This is another sweet plugin. It's called KOPF. Another one, just if you guys are playing around with this. It's not as like quick and easy to see what's going on, but it allows you to modify your mapping really easily. So we've provided the mapping. The mapping is like the most important part for the health of your nodes, the total health of your cluster. Without this mapping set up properly, you're gonna need like 100 nodes for when in actuality you only need like 4. It depends on your analysis, and if you're using analysis, just for most of the stuff that you guys do, you don't need to do keyword analysis on IPs and stuff, for example. Okay, so let's just show a quick little video of how to actually just quickly go ahead and receive data from the stream that we've given everyone here. So really quickly, you just kind of create that logstash config that we showed previously. You execute it. You're able to pull up a bunch of workers as it's starting. Here's the interface for RabbitMQ. You can see the phdays user. The password used to be phdays, but it's not anymore. And then we can see that we're actually now receiving the same amount of data as that our other nodes are. And we're just putting this into a local VM. And then we have the ability to do whatever we want. In this specific instance, we've got a small Kibana 3 box in there, the old school Kibana, my favorite. And we're loading up our connections dashboard. So you see here, we can quickly start to analyze our data in real time. And what's interesting about this is there's actually an attack going on as we're analyzing the traffic and analyzing the data here. We can see who's receiving packets. This is all connections overall. We can see that China is receiving an NTP flood right now, as well as the US. And then we can switch over to like another dashboard, for example. We can refresh the data, pulls in more. We can jump over to another dashboard if we want to visualize like another data set. We found that creating different dashboards for different data sets was the best way to go. So like if we want to look at NTP floods, we just create an NTP dashboard, DNS floods, and DNS one. Here's an example of the DNS flood. It sees one packet. This is pretty interesting. They're using empty queries for the reflection. They're shipping off all the route traffic for the reflections. Pretty cool. Not a huge thing, but there's no domain needed to actually reflect. So you can see here Ukraine's getting attacked. Thought that was pretty cool for phdays. Okay, so this is all the raw data. What we do to actually turn that into the process data is every day we run a Python script to go back and query the Elasticsearch data. All that is open and available to everyone as well. So the way that kind of looks is it just kind of comes onto the butt of Elasticsearch right here, queries it back. What we do is we just have a cron job on the STD clinic. The STD clinic generates all of our reports. What it does is it goes out, creates relax asserts, creates the JSON files, sends them off into the email for everybody, and then ships it off into the APIs for people that need to receive that data in API format. Key things, keeping them simple is the best way. Like little things like this, the simple things, actually never really broke. So best approach. Yeah, we're really slow on minutes. One of the hardest things we had to do was actually finding sources to hosting providers. Anyone wants to talk about that, they can buy me beers later. I'd be more than happy to explain it. Let's get into the code really quick. I'm sorry, guys, I have to speed up. We use a mixture of code. We use Bash, Go, R, and Python. We were using C, but I'm a horrible C developer, like really bad. And someone emailed us like, "Hey, this shit's really vulnerable."
So our honeypots were becoming really interactive there.
So I was like, "All right, cool. I'll switch it over to Go."
Who owned us today?
Go works really well. I have a template up, so anyone that wants to create like a quick reflection service emulator, it's right there. You just pop in some packets and you're good to go. Really simple, bitewise operation. Super happy with it. Bash for deployment and some like cron jobs. R is really awesome for visualization. I'm a huge Python programmer, but when I came into R, I just fell in love with its ability to create graphs. My favorite thing about R is its legends. So I'm really big on legends and making sure all the colors match up and everything like that. It's great. All that code's on there too. It's in the data R folder. So Python creates the file. One of the things, the tricks we learned for creating all of our queries is we used Kibana 3. There's a little thing, I'm sure everyone can see it, that little dot right there. You click on the dot and it'll give you the raw query. So that query you can quickly pipe over into Python and generate it. It's really easy because you can see what you're going to visualize first and what you're going to query, and then you can get the raw code back into Python. So last quarter, we saw like 100,000 attacks. This was pretty cool. Now, these are attacks per day. So like, let's say, for example, a source IP runs a DNS attack like 5 times, but it's the same thing, it's a DNS attack. We still don't count that as one because we calculate whether it's an attack or a scan in that 24-hour block. So we saw 100,000 attacks in a short period of time. I think that's a lot. Here's again the providers. So we see in the top 10, there's no DDoS mitigation service providers. Crazy. Again, I'll talk more about these statistics with anyone later, but we're running really, really short on time. Where are we at, like 10 minutes? Cool. And I still want to leave some time for Q&A. So this is a breakdown of attacks. This is another quick thing that we noticed. Once we started taking our emulators and bringing them from C and moving them over to R, into Go, we saw that they were being used more. Again, horrible C coder. So now we're seeing a lot more attack diversity. And we see attackers actually using a lot more attack diversity, although in its main form, they're sticking to the core services that they love. There's always the top targets. Usually it's like US, China kind of fight for first place. Turkey in Q4 was #1 target for a while. I don't know why about that, but they got hit pretty hard. They got hit more than anybody. They actually like caused us to have to upgrade all of our monitoring nodes. And then, but yeah, they usually jump around. Russia's usually like in the top 10, but they're usually pretty good about getting hit. They don't get hit that as much as those other countries. Here's our breakdown. So you can see, like whereas before we saw the majority of the attacks being NTP. NTP is orange, in case I'm sure you can read these little colors, but NTP is orange. DNS is green. It's actually the same in all the slides. So you can see here that the one to the left is just October of 2015, and then this is Q4 of 2016, so the first 3 months of this year. We've seen the majority of the attacks being NTP, second DNS, this is ChargeN, and this is SSDP, and then this little sliver is all the other services that we're monitoring. Here's a breakdown of all of the services duration. So each little bubble is an actual attack. It looks like a soda pop graph, right? But what we're really looking for here, that's why we got the jolt cola down here. What we're really looking for here is our duration means. So in the 92% of the attacks, from like above 8% and below 92%, what's the mean? And we're noticing in our large data sets, those are right around 300 seconds. So this is a good indicator that there's a lot of DDoS for hire services that are using the reflection services.
Yeah, those are the booters we're talking about because you only need about 5 minutes in order to win the game.
Well, it's also the cheapest and lowest barrier of entry for entering in at cost, right? So in DNS, it's very prevalent. You can actually see these kind of lines appearing. these denser lines. And these are very good indicators that these are strong sections of where the attacks are being run. So you can kind of make the assumption that, okay, like these are the times that are being executed, predetermined on these tools. These aren't just random packets. You know, being that the data set's open, some of the data set things that we haven't published in the past, but you're able to do is you're able to process this data in any form. We're really open to that. You know, here's, for example, all the DNS amplification domains for Q1. I can barely even see it. But like msk.ru, I guess, was like the #1 used. As well as transaction IDs kind of get brought up. These were some of the guys that helped us out with the project. If you ever see either one of these guys, Zane Witherspoon or Achilles Moustakis, I always mess his name up, definitely hire them. They're badass, love them to death, great guys. I want to thank them for their work that they participated on with the project. You can go ahead and get a copy of the whole project on GitHub. Here's the URL. I'll keep it on the next slide as well. I want to give special thanks to A10, NexusGuard, FSI.io, and Carry.net for helping us out with the project as well. Here, I'll leave you another link to the URL.
That's about brotherly love here.
But before jumping to questions, I do want to thank you guys. You guys are freaking awesome. Love the country so far. It's been amazing. Your hospitality's been great. I look forward to drinking with every single one of you tonight. Okay, so I think that's about 5 minutes for Q&A, right?
Yeah.
Where'd those T-shirts go? They were like here. Hold on. I'm gonna start with like throwing one. Oh, that way. I was supposed to pick. I just wanted to throw one in. All right. Does anyone have any questions? Maybe you. No, questions or T-shirt? You still want it? Is there any questions?
Yes.
Okay. Hold on, let's wait for the mic. I didn't even finish this beer. This is full.
Could you tell about the most global attack you've ever deal with?
Do you want it like the worst attack I've ever dealt with? Yeah. The worst attack I ever had to deal with was a multi-year event. It was politically. It was politically motivated. It come under a bunch of different fronts. It was a bunch of different guises. They used anonymous. They used the guise of these other people. They used the guise of a Palestinian hacking group. But essentially, it was when Iran targeted the U.S. financial institutions for multiple years.
Yeah, and actually, you probably saw the indictment came out about 4 weeks ago.
Yeah.
So it's
It was
public now.
It was by far the most challenging DDoS event I've ever had to deal with in my life, and the most fun.
Thank you.
I think I bid you further adieu, unless anyone wants to scream and holler. You can find me at the bar. I got one more T-shirt, but I think she won. Good catch. Thank you, everyone. I'll see you at the bar, all right?
Thank you.
Yeah.